Assalamualaikum and very good day to all the panel. I'm Nur Munirah binti Sulaiman and I will present my final year project entitled High Density Polyethylene HDPE in Green Waste as Construction Material. This research was conducted by me under supervision and guided by my supervisor and co-supervisor, Dr. Maidiana and Encik Zulkifli. Now, we go to the introduction. Plastic is an integral part of our daily life. Its production and consumption have been rapidly increasing due to its wide applications. However, because most waste plastic does not decompose naturally in landfills and leads to air pollution, it is not environmentally safe and poses a severe environment problem. Plastic of poor quality, such as those used in food packaging, are rarely recycled. This is most likely why our landfill overflow with low quantity plastic wrap and packaging. As a result of Malaysia's limited ability to recycle plastic, it makes sense for us to minimize our plastic usage. Malaysia is tracking global trend in over plastic waste creation and single-use plastic consumption and has been the world's top importer of plastic waste since 2017. High-density polyethylene (HDPE) has become a popular polymer widely used in industrial and commercial items today because of its characteristics. HDPE has compressive strength and it has high resistance and melting point. In addition, using plastic to determine its compressive strength will help the industry achieve its objective. The opportunity to use this will conserve the environment and reduce the environmental threat of landfill and marine pollution. The objective of this study is to determine the compressive strength of high-density polyethylene (HDPE) plastic waste using Universal Testing Machine (UTM). Next, to compare the deformation pattern of HDPE plastic sample. Next is the scope of the study. The study of this project is to decide the size of the mold with a square shape, which is the form of testing specimen according to ASTM standard D1621, the standard test method for compressive properties of plastic. Next, the HDPE will be tested using Universal Testing Machine. It then used the standard high-density polyethylene mixed with recycled high-density polyethylene following the determined percentage. After that, the compressive test was done to examine the compressive strength of the mixture. The compressive test result of each mixture was tabulated. Finally, the highest compressive strength and durability mixture is selected as the best percentage and compared to the deformation of each pattern. The methodology of this study starts with the material used, which is standard HDPE and recycled HDPE. There are two sizes of mold that was chosen in this study, which is 70 mm times 70 mm times 50 mm and 70 mm times 50 mm times 70 mm. In this study, there is 3 mixture of HDPE plastic according to the percentage. The control sample is needed to ensure the test and the result analyzed are stable. For sample preparation, using an analytical balance laboratory, the plastic HDPE obtained from the factory is first weighed according to the mix design. Then the particles were put in the mold and heated inside the industrial oven for 1 hour at 180 degrees Celsius. After that, the plastic is then removed from the oven to be compressed to avoid holes. The sample is allowed for a while to harden. The mixture was molded in a square shape. Next, the sample was trimmed by the milling machine to get the needed size and shape according to the standard. The process was then repeated for 3 samples of each mix design. Finally, the preparation occurred at an environmental laboratory in UPNM. Next, for the comprehensive test procedure, a comprehensive strength test was carried out in structural laboratory in UPNM. Then, the machine used is in the UTM machine. The specimen was prepared as described in the standard. Next, the sample was placed between the compression platen, ensuring it was aligned with the center line of the platen. Finally, the test was stopped when the sample is compressed by 30% of its height. The force and deformation data were recorded. Now we will go for the result and of the experimental analysis. The result of the experiment showed that the comprehensive test on the force and the displacement for 2 different sizes, which is 70 mm times 70 mm times 50 mm and 70 mm times 50 mm times 70 mm for a sample size of 70 mm times 70 mm times 50 mm. The highest force obtained is 109.783 kilonewton, and for 100% recycled HDPE plastic, and the lowest result obtained is 79.937 kilonewton for mix of 70% standard and 30% recycled, while for the 70 mm times 50 mm and 70 mm sample, the highest forces was also obtained for 100% recycling, which is 80.48 kilonewton. So we can see that the 2 different sizes do not affect the sample strength. Next, we will look at the average compressive strength from the HDPE sample test. It can be seen from the graph that 100% recycled DPEs has the highest compressive strength among other mixture and perform the best compressive strength, which is 0.023 kilonewton per millimeter square and 0.022 kilonewton per millimeter square for 2 different sizes respectively. Next, a few of the deformation pattern for the HDPE sample are shown in this figure. After testing, we can see that all the samples have the same pattern and don't show the change of pattern because it's only compressed at 13% of their original height. The conclusion from this study is the mechanical property of standard HDPE are much lower than recycled HDPE. Secondly, the 2 different compressive strength sizes increase linearly for all mixture. Lastly, the plastic block can be used to replace the interior decoration walls and partition walls as a construction material so that we can save the use of stone, sand and other construction material because of the price and more environmentally friendly. However, a recommendation can be made in this study or should be done by experimenting with its physical and chemical properties to know how it affects recycling HDPE. That's all from me. Thank you for your attention.